this video we will discuss the problem next right node. The problem says that we'll be given a binary tree and we'll be given a key in the binary tree, and what we have to do is we have to find the node right to the given key. So if there is no node towards the right of the given key, in that case we have to return the value as -1. So let us first of all take the sample example for better understanding. So suppose if the sample example has been given like this tree. So in this case, if we will look at this particular tree that has been given to us, so let's quickly see. So 10 to 6. So first of all, we'll have 10, right? So first of all, let's say we have 10. Then 10 is connected with 2. Then 10 is connected with 6 to the right child. After that, we have 8. Okay, for 2 we have 8, and the right child for 2 is nothing but 4. After that, for 6 we have the right child as 5. So suppose this is the tree that has been given, that is 10 to 6, 8, 4 and 5, and you have been given the key value as 2. So if you have been given the key value as 2, so basically what you have to do is you have to tell that what is the right node of 2. So the right node of 2 is nothing but 5, is nothing but 6, you can say, right? Basically the right node of 2 is nothing but 6. Suppose if I was given the key value as, let's say, 4. So what is the right node of 4? The right node of 4 is nothing but 5. So we'll return 5 for that. If I was given the key value as 5, so for 5 there is no right node towards it, right? So in that case I'll return a -1. For 8, what is the right node? The right node for 8 is nothing but 4. So that is what I have to do. For each, like for every key that will be given to me for a particular tree, I have to simply return the rightwards node of it, right? For basically for 6 there is no right node, so I'll return a -1. So that is what I have to do in this problem. And if you will observe, so obviously for a particular node, the node towards its right side will occur if and only if I'll check in the same level, correct? Because if I have to check for 6, so if there is a node that needs to lie towards the right side, so basically I'll be checking for a particular level only, right? I'll be, because for 2 the node towards its right side will lie on the same level as 2, correct? If I have to check for the right node of 8, so I'll check on the same level as 8. So basically if I will think about this, so which algorithm comes to my mind for this particular tree? So the algorithm that comes to my mind is nothing but the breadth first search algorithm, right? Basically the level order traversal, because I am traversing in the level order fashion, right? Because if I have to get the, like if I have to get the right node for a particular node, in that case I have to traverse in the same level, and that is nothing but the breadth first search or the level order traversal. So this is the first intuition that comes to our mind. Now how can we do this particular thing? So what we can basically do is, suppose if we have been given the key, suppose the key value has been given to us as 2. So how can we do it? So first of all we'll make a queue for ourselves, okay? So first of all we'll declare a queue. In the queue what we will do is, first of all we'll insert the root node, so we'll insert 10 inside the queue, and then what we'll do is we'll start the traversal, okay? So after we start the traversal, so we'll check, like we'll first of all take out the current. So current will current node will be nothing but the node 10, okay? And what I will now do is I will now check. So does the left child exist? Yes, the left child exists, right? So also one more thing, we have to also check for the level, right? Because for, if suppose I am checking for this level first, then this level, then this level. So suppose if I reach somehow I reach 4, right? If I reach the node 4, okay? So in that case what I have to do is I have to get this value 5. So for that I should be having a track of the levels as well. So what I will be doing here is I'll be having a size. So initially, like every time while I'm starting the BFS traversal for a particular level, I'll have the size to have an idea about the number of nodes in the particular level. Okay, so initially the level is there's only one element, so the size is 1. Okay, I'll take this out. After this, like every time I'll be decreasing the size one by one if I keep on popping. So current will be equal to 10. Okay, now what will happen here is, if I see, so this node is 10. Okay, so now if I see, so is it equal to the key? No. So what I will do now is I'll basically, after taking it out, I'll pop it out as well. Okay, when I pop it out, so you can see that basically I will start from 0, I will be lesser than size. So basically I'll be iterating through one node. Now once I've iterated through this node, so I'll check for its left child and right child. So its left child is nothing but 2. So I'll insert 2 into the queue, and after that I'll insert the another node, that is nothing but 6. That is the right child, because it also exists. After this part is done, so what we'll be doing is, now the traversal for the level 1 is done, because what I did was, for traversing through this level, I said that okay, I can start from 0, I is lesser than the size, and then I plus plus. Okay, and I was traversing through all the nodes. Now if I see, so basically when after that, when I was 0, then I was at this level. Okay, I was at 10. Now there's no other node, so that's why I will be equal to 1, and when I is equal to the size, in that case I will stop. So now I'll stop, and again I'll take out this, like when I come out of the loop, so again I'll take out the size, new size. So what is the size of the queue currently? So the size of the queue is nothing but 2 now. Okay, that represents that, okay, there are two nodes in the current level. So if there are two nodes in the current level, so what I will be doing here is I'll again run a loop from, for I starts from 0, I is lesser than now 2. Okay, so I will be running for 2 times. So this will be 0, this will be 1, right? So basically this will be 0, this will be 1. So what I will do here is I'll first of all take out the current node from the queue. So basically 2 will be taken out. Okay, so I'll take out 2. It is the 0th node. Now is it equal to the key? Yes, it is equal to the key. So if it is equal to the key, then how, like, is it equal to the key? Yes, it is equal to the key. So if it is equal to the key, then what is the right element of it? Can I say that the right element is nothing but 6? And if I'll observe clearly, so I can say that that in the inside the queue, inside my queue, the element that is stored currently at the front, that is the right element, correct? Because I have popped out 2 from, like, current element is 2, and basically I have popped out 2 from the queue, and the element for towards the right side will be nothing but 6, and that is present at the front of the queue. So if there is a right element existing for the particular key, in that case it will be nothing but the q dot front. You can observe this part from it, right? And another thing that I need to observe here is that if I see the I value, so I value is here 0. So basically I value is not equal to the last, right? If I see here, so basically size is what? Size is 2. So if I was equal to suppose 1, right? If size is 2, then I can either be equal to 0, and I can either be equal to 1. So if I was equal to 0, in that case I was at this 2. So for this 2, the right element is present. But suppose if that was not the case, like when will the element not be present? Because if suppose that I was standing at this 6, so for this 6, this is the last node of the current level. Basically this is nothing but at I is equal to 1, this element is present at I is equal to 1. So in that case there is no right element present for it. If there is no right element present for it, in that, like, how can I identify that? So basically if I is equal to the size minus 1, in that case there will be no right element present for that particular element. And the queue, like for this particular level, even if the, like, let's say for 2, so after processing 2, 8 and 4 will be inserted inside the queue as well. But for 6, there is you will have 6 inside the queue. You will be iterating on 6, but you will not have any elements towards the right of 6. Although the queue will have some elements, but the front element, the current front element, after popping out 6, while you are at 6, the front element will be 8, and that is not the right element. So in that case, I have to return, like, I have to check, and I should be returning a minus 1. So basically that is the case here, that if if I is not equal to the size minus 1, because we are taking a 0 based indexing, so this node is 0, this node is 1. So if the key that I am checking, if the key is equal to the if the key element is present at the index, that is I is equal to size minus 1, in that case I will not have an answer because there is no right element for it. Otherwise, if I is not equal to the size, uh, in that case, if there are several other nodes in the current level, and the this 2 is there, suppose, so it has a right element for it. So in this case, you can see I is equal to 0, which is not equal to size minus 1. So in that case, for the right element will exist for it, and that will be nothing but the q dot front. So that is how I'm going to do this particular problem. Now talking about the time complexity of the approach. So time complexity will be nothing but order of 1, order of n, because in the worst case, I'll be iterating through all the nodes, and the space complexity will be order of n in the worst case, right? So let's try and code this approach quickly. So what I'll be doing here is I'll first of all declare a queue. So let's declare a queue first of all. So I'll have a queue. Let's say it will be storing the nodes. So I'll have queue node star and then queue. Okay. So I'll first of all push the root node into my queue. Okay. After this part is done, so what we'll try to do is we'll also have the, like, we'll start the traversal for the current level. So while the queue size is greater than 0, I'll be traversing through it, and I'll simply take out the current node. So before taking out the current node, I'll take out the size. So because I'll be iterating on this particular level wise, right? So I'll be doing a level order traversal. So that's why I'll have a loop which will not add to my complexity, but it will help me to keep the level separated. So I will start from 0, I is lesser than the size, I plus plus. This loop is nothing but to traverse for a particular level, right? Okay. So after this part is done, so what I'll do is I'll take out the current node. So I'll say that, okay, node star, the current node is nothing but q dot front. So I'll take out the front node of the queue. Once I've taken out the front of the node of the queue, so I'll pop it out as well. Okay. And another thing now I'll be doing is I'll check that if the, let's say, the current's left child, okay, if for the current node its left child is not equal to null. Okay. So in that case, what I'll do is I'll simply say that, okay, I need to push the left child into the queue. So I'll say that okay, current dot left, you simply push because it is existing, right? Similarly, I'll check for the current nodes that if the current nodes right child is not equal to null, okay, in that case what I'll be doing here is if it is not equal to null, so in that case also I'll simply say that okay, let's push into our queue the right child of the current node. Okay, that is what I'll be doing. And another thing that I need to do is, like, if suppose that I is equal to the size minus 1, right? If I is equal to the size minus 1, in that case there will be no right node existing. So I will check that if I, like, if it happens that the current node data, if it's equal to the key value, right? If it's equal to the key, so if that is the node that like that is the node for which I was looking for the right node for it. So in that case what I will check is, I'll check if I is not equal to the size minus 1. So if I is not equal to the size minus 1, so in that case basically what we can do is we can simply return the q dot front, because q dot front will be storing that particular node. Because if you will observe in this case, when I was talking about the problem, when I had taken this particular test case, in this case when I was traversing through, when I was having the current node as 2, when in my current 2 was stored, right? When my current was 2, in that case the next node, like the front of the queue, was 6, and that was nothing but the next node for 2, because I was not equal to the size, because I was not equal to 1. If I talk about 6, so for 6 there is no next node towards the right side, because I is equal to the size minus size minus 1 for this particular level, because there are two nodes and size is 2. So size minus 1 is 1. So in that case for 6 there is no right node available, but for 2 the right node is available, so I'll have it. Okay, so that is what I'll be doing. And in this case, suppose if I do the BFS traversal, and for the key node, key value, like for the particular node for which I wanted to find the right node, if it is not available, in that case I should be returning nothing but a node with the value is minus 1. So in that case what I'll do is I'll say that okay, I'll create a node star, and I'll simply have a answer is equal to nothing but new node, and it will have the value as minus 1. So if it happens that my node, like if there is no node existing for the particular key towards the right side, in that case I'll simply return nothing but the minus 1 as the node. Okay, let's try and quickly compile this code to see if there is any error in this particular code. It works on the samples, because for this particular tree it gives us the output as 6. That is what we were expecting. Now let's try and submit this code. So you can see that our solution is working on all the test cases for this problem. So if you understood this problem, make sure to hit the like button, comment down understood as well. Thank you.